Hi, we're back again. Scoof. We've got a Ghidra Automation video this time, so same but different from the Binary Ninja video. So we're using Ghidra. We just swing over to the notebook. So again, setting up some Python modules or some dependencies that we need just to make Jupyter work the way we want to, so we can process data and get some nice charting going on. And as with the previous video, what we're doing is setting up a Ghidra script this time to do pretty much the same thing that we did before. So we're looking for potentially dangerous functions, and this time, the syntax is obviously slightly different, and the way we go about some of this is a little bit different as well. But broadly speaking, same overarching process applies. So within Ghidra we have something called current program, which gives us various attributes, artifacts for free, so we can use that to get the file name, get the use Git language, which gives us the architecture, the endianness, whether it's 64, 32-bit, all that good stuff. And then obviously we can also get the hash of the binaries. We can go through, iterate, get all the strings, get all the functions from the binary, calculate the average psychometric complexity, and obviously what we've really come here for is to find cross references to systems. So do we have potentially vulnerable calls to system? So we can go through, do all of that, and then set up this time we're setting up a CSV to take those attributes, put them in various columns, and then we can create a pandas data frame from that. So once we've created this script, what we'll do is we'll make it executable. Then we'll tell Jupyter, hey, this is where our headless analyzer sits. So obviously it's in the Ghidra install folder, wherever you've put that. That's where you want to point that to. And then we'll say, hey, this is the path where we have the binaries that we want to iterate over, and this is where our scripts and projects will live. So it's just like a temporary area to store the processed data as we're going along. Then we use some of the Ghidra preferred nomenclature to execute all of that, and that obviously run, and it's actually still running because I kicked this off before we started. I feel like Black Dynamite. I threw that script before I walked in the room. But yeah, so we'll let that run, and we'll be back in a second. And we're back, thanks to the magic of editing. So the script has done its thing. So what we're going to do now is load up that CSV into a pandas data frame. But this time we're going to basically name all of the columns, because we didn't do that this time round. So we've assigned the column names, and then we just get rid of any cells that have not a number in there, because we're not going to do the old Batman theme tune and go na 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 na, which is a terrible joke. I do apologise, but hey, it's free. What are we going to do? So we load up that data frame. As you can see, we have a column with obviously the file names. Then we have the architecture. So as said, with the Git language, you get the architecture, the endianness, and whether it's 32-bit, 64, all that good stuff. And then we've got obviously the corresponding hashes, list of strings, list of functions, then the xrefs to systems that we were interested in, and we've added obviously another column that gives us the total xrefs to system, and then the average psychometric complexity. And as you can see, same number of binaries as before, so we've got 15. And we'll go through and just, as I said before, with difference between CSV and Parquet file formats is that with Parquet it does its best to maintain the file type, but with CSV it's like, hey, you're just getting a bunch of objects and you might get some ints, you might get some floats, but who knows? We might interpret it as a date, or we might not. It might be like Excel, or I won't do the rest of that joke. But yes. So yeah, we again we can go through, change those data type strings, so then we can do our searching across the data frame and say, hey, for the architecture, find me anything containing big, please. So what we look for is any endianness that is big, and it will come back and report that here. So we've got, what have we got? 1, 2, 3, 4 instances this time, and then we can obviously use that the power of a query, which again we get for free in pandas, to say, hey, for the average psychometric complexity, give me any that are greater than 3, and we have that here, and we can also create a pandas Boca interactive bar chart, and have that in ascending or descending order, whatever we prefer. And remember kids, bar charts, pie charts, PowerPoint, Excel, it gets you promotion. I hate to say it, but it's as painful as it is, but it's also true. And obviously we've got various other versions of slicing and dicing the data to give us average psychometric complexity and that sort of thing. And again, here are some references. So we've got some pandas references in terms of how to use pandas, how to make charts, the Ghidra API, some Ghidra snippets from John Setfall, and some other videos from him, on how to do some of this stuff in a little bit more detail. So before I go, quick word on the API. Some people rave about the Ghidra API, saying it's great, it's well documented. In comparison to IDA, I would say yes, that is true. In comparison to Binary Ninja, I would say not so true. Some of these things feel like, obviously they have a 20 plus year legacy, and some of these additions seem like an after for a feature request. So there's a bit more gymnastics required to get certain things to work, and some of the documentation is sparse in areas. The help documentation for Ghidra is fantastic. I would say the contractors did that, probably not the same contractors did the API documentation, just a guess, but I believe it to be true. It's my favourite bias, confirmation bias. Anyway, on that wonderful note, I will see you again soon. Take care.